Hello class, these are our notes for informal geometry. The section today is 7.2, similar polygons. So the first couple sections in the chapter we learned about ratios and proportions, and now we're going to use them when we're looking at similarity. So first is our definition of similarity. Two polygons are similar if their corresponding sides have the same ratio. And we could abbreviate corresponding. Sometimes I just write CORR, but I want to make sure that I write out the full word. You can totally abbreviate it, but just so that you know what I'm actually writing. So corresponding sides have the same ratio, and that their corresponding angles are equal or congruent. So corresponding angles the measures are equal, the angles are congruent. I guess it depends on how you word that. So really to me, I always think about similar as being like a copy machine, right? Like you have taken, in this case, we look at that smaller quadrilateral EFGH, and it's almost like we resized it on a copy machine and made it larger. The symbol for similar is this, it looks like just the wavy line that we would use for the top of the congruent, but there's no equal sign with it. That means similar. So this is saying ABCD, so that shape is similar to the shape EFGH. So again, that means that their angles are congruent, and a ratio of the sides, I'm just making different kind of markings on all of these to keep track of them, and a ratio of the sides would be the same. So BA would be the same as FE. That ratio would be the same as BC to FG. So let's go through and just write down the angles are congruent and the sides have the same ratios. So if I'm making a list here, angle A would be congruent to angle E. We have to match them up in exactly the same order, B and F. C and G. D and H. Then when I write my ratios, I have to decide if I want the small one on the top or bottom. I think I'm just going to go left or right. And so I'm going to write AB. So that's AB is right here, and that's going to match up to this side. So I'm going to say AB divided by EF is equal to, next side I'm going to write BC and FG. And so if we divide these out, they all have the same ratio. Like maybe the red one is twice as big as the blue one. So everything would be 2/1, for example. Let's see, CD divided by GH. I'm giving letters like in that same kind of order as I go around the shape. And that would be equal to DA over H. Pretty sure that was an E right there. Okay, so we do have an example at the bottom here now that we're going to go through. So first they tell us that the triangles are similar. Remember this squiggly line here means that they're similar. We want to first go through and list all of our corresponding angles. So we could look at the picture, but we could also just look at the order. So P is the first letter. That's the one that's going to be similar, or sorry, it'll be congruent to S. So our angles are congruent. So P and S. Middle letters are R and Q, so angle R congruent to angle T, R and T, and then Q and U. I might have said the wrong letter at one point, but I did write down the correct one. I feel like I said a Q when I didn't mean to at some point. And they also match up here, right? I can tell that Q and U match up. I can tell that R and T match up, but it's really easy to just take them off of this. Now we want to know the ratio of the corresponding sides. And they don't tell me which way to write it, so I could choose to write big over little or little over big. So I'm going to go ahead and just choose big over little. So this side, PR, is the first two letters, so I know that matches up with ST. So I'm going to write 10 over 8 equals, just go around the shape, 20 over 16, which is going to equal 15 over 12. And I could either divide those out on a calculator to prove that they're equal and write a decimal for each of them. That might be the easiest way. So if we do 10 divided by 8, so you put the 10 in your calculator first and then divide by 8, you get 1.25. But the other way that I could just prove that they're equal and then do the same thing on the next one and the same thing on the last one. The other way that I could prove they're congruent, though, is just by reducing them all and getting the same fraction. So I do think we need some practice at reducing fractions. It seems to be tricky for a lot of people. So the first fraction, I would divide by 2 over 2. You don't have to show me this step. It's just something I find helpful for students to see, and I would get 5/4. My second fraction, they're both even. I could be dividing them by 2, but I have an even bigger number that divides into both, and that's 4. So I'm going to divide them both by 4. 20 divided by 4 is 5. 16 divided by 4 is 4. So we're trying to divide out the biggest number we can from the numerator and denominator. On the last one, I can divide them both by 3. 15 divided by 3 is 5. 12 divided by 3 is 4. So you've got two options. We could try reducing fractions, or we could just divide them out. And again, when we divide them, in my calculator, I do 10 divided by 8, so the 10 goes in first, or 20 divided by 16. So either way, we can see that all of those ratios are the equal. So we're going to go ahead and write yes for this next question. And then it says, what is the scale factor? So that's like what I would multiply one shape by to get the other one. So if I want RPQ to TSU, I always want to think about, is that the big to the little or the little to the big? And RPQ is the one with the bigger numbers. So I'm going to write big to little. And remember, whatever we write first in one of these statements is what's going to go in the numerator. So that means I want to have big over little like that. And that's what we already came up with. So I could write 5 to 4. I could write 5 dot dot 4 like this with a colon. Or I could write it as a fraction. We tend to like fractions the most because, of course, this is a math class, but there's different ways to write that scale factor. So now we're going to go ahead and look and see. It says determine whether the polygons are similar by showing the ratio of their sides. So in our first example, we said, hey, they're similar. Let's look at how the ratios are equal. On the next one, they're saying, hey, here's some triangles. Are they actually similar? So we're going to be checking to see, do the triangles have a ratio that's equal for all those three sides? So I can see that the angles match. That's the first part of being similar, right? But then I also have to check the sides. So I would compare the side that's 6 to the side that's 9. So I'm going to write that as a fraction. So 6/9. My next fraction would be 12/18. And the third fraction would be 8/12. So I either need to reduce all of these or divide them all out. So we're going to practice reducing. The first one I could divide by 3 on the top and bottom, and I get 2/3. The second one I could divide by 6. So we're always trying to divide by the biggest number we can. Get 2/3 again. The next one, let's see, what can we divide 8 by? So let's say we divided them both by 2 because they're both even. And then we get 4/6. And then we said, well, that can still be reduced again. They're still even. I could divide by 2 one more time, and then we get 2/3. So those are all equal ratios. Therefore, they are going to be similar, right? And I can write a similarity statement. So don't be discouraged if, like on the second one, you don't know the biggest factor to divide out there. So sometimes you divide again, you could keep reducing. It's not like if you don't guess that biggest number on the first try, you're done. So we have two similar triangles because the ratios are equal and the sides are congruent. So I'm going to write triangle. I'm going to start at the angle that has one angle arc, and then two angle arcs, and then three angle arcs. Remember, we have to write them in the same order, just like we would if they were congruent, but they're not congruent, they're similar. So XYZ is similar to triangle. And then I'm going to do the next triangle in the same order. So DEF. What is the scale factor of FED to ZYX? So is this big to little or little to big? So FED is the bigger one, so this is big to little. So I'm going to actually take this 2/3 that I got up above, and because I want the big one on top, I'm going to flip it and write 3/2. So the next one, they tell us that we have similar triangles, but this time we're using it to find the value of x. So this is where it gets interesting, and we're going to put everything together for the chapter. Oh, I guess I'm up here. This one doesn't say find x, but we're doing the same thing, or solve for x. So we're going to set up some proportion to equal ratios, because we know that the triangles are similar. So I know this side 12 is going to match with 24. So 12 divided by 24 equals, and then my second ratio is going to be x over 18. So now that I have a proportion, I can go ahead and solve. And sometimes on this one here, especially like 12/24, right away my brain is recognizing that 12 is 1/2 of 24. So I'm going to rewrite this as 1/2. And then I could look at this and use some common sense to figure out my answer. I could think, well, 1 is half of 2. What number is half of 18? Or I could go back to my cross products again. So my cross products or my means extremes theorem would say 1 times 18 is equal to 2 times x. So I am all for like using some common sense on this one, but this is how you would show the math work if you really want to do it this way. When we solve, we get x is equal to 9. Same idea on number 7. We know we have similar triangles, so let's go ahead and set up a proportion. So x on my first triangle is going to match with 9 on the second. Those are similar, and I can tell that because R and T are the first and third letter, G and J are the first and third letter. I can look at the shape and just tell which sides match up, but that's always an option if you're not sure. You could look at the letters and the shapes. I'm trying to get my eraser here. I guess it's working. I didn't see it selecting it. So x divided by 9, or x over 9, we have a ratio equals, the other one would be 8 over 12. So the big thing is if I start on the small triangle for the x, then I start on the small triangle for the 8. So 8 over 12. And lots of ways to solve again. Maybe I don't know how to reduce 8/12. If I didn't know how to do that, I could just go right ahead with the means extremes theorem or cross products. X times 12 is equal to 9 times 8. So 12x equals 72. And then I would divide both sides by 12. And x is equal to 6. One more problem here where we're going to do the same thing. We're going to set up a proportion and solve. This one has a lot of different options. It gives me all 3 sides, but I only really need 2 sides. So I'm going to match up x off the big triangle. We can have the big one first, it doesn't matter, with 9 on the second. So x over 9 is equal to, and then I could use 16 and 8, or I could use 14 and 7. It doesn't matter. So 16, starting with the big triangle again, over 8. And I happen to know 16/8 is just, I can divide that out, right? It makes 2. So x divided by 9 equals 2. But it's hard for me to set up a proportion if I don't have 2 fractions. So I'm going to make this 2 over 1. And then we're going to go ahead and use cross products. So x times 1 equals 2 times 9. 1x is the same thing as x. 2 times 9 is 18. So this is really the kind of the whole gist of the chapter, is we're looking at similarity. So today we're putting those pieces. First of all, what does similarity mean? So make sure you understand that. It means we have corresponding angles. It means that we have similar sides, or sorry, we have the ratios for sides. I'm mixing all my words up now. So we have this common ratio all the way through. They're corresponding, they're equal. Um, just this idea that we can set up and solve a proportion to find a missing side is pretty cool. And also that we know how to rate these scale factors as well. If you need help, please make sure that you ask.